Okay, good evening, everyone. Hi, good evening, Nikolai. I'm just waiting for a few more to join us and we will begin. Evening, O'Neill. Okay, I'm gonna start here. So this afternoon we'll be looking at factorizing of okay, Aaron, see if it's working there. Okay, could you hear me now? Okay, can you see and hear now? Just let me know if you could see and hear now. You should be able to see and hear. All right. I'm gonna restart. I'm just gonna restart this, okay? Just wait around, yeah? Please. Wait around. I'm just gonna restart it. Okay, could you all tell me if you could see now? See and hear. Just indicate to me if you could see and hear, please. Okay, can you see and hear now? Tell me if you could see and hear now. All right, good. I'm not sure what's the issue. Probably the software just needed restarting. All right, so thank you very much. Let's get down to class this evening, okay? All right, so we will start off here with factorizing difference of two squares. So what I want you all here to do is to prove this identity. Now remember I told you all about identities. Identities are where everything on the left hand side, this expression here is always equal to this expression here. Okay, when you expand it out. So I want you all to prove this. Expand this out, a minus b by a plus b. Expand it out and show that this, when you expand it, will give what's on the right hand side. Okay, I'm going to start to expand here. I'm going to take the first bracket here and break it up into terms here. So a, and we're going to multiply by the second bracket with each of these terms. So this is a by a plus b minus b by a plus b. So a by a here is a squared. A multiplied by ab. A multiplied by b is ab. A multiplied here by minus b is minus ab. And minus b multiplied by b here is minus b squared. Now notice very carefully here, this subtract each other, so you just go eliminate. Okay, so what you remain with here is a squared minus b squared. So a squared minus b squared is the same as a minus b by a plus b. Tell me if you all get that. Okay. All right. So as previously, as you would have done with the perfect squares, this you will memorize this. Okay? It comes in really useful to know that along with the perfect squares. Okay? So that expression there will help us with difference of two squares. So I'm going to do two examples here with factorizing difference of two squares. Now, this is a question that comes almost every year in CXC. So, in your CSEC mathematics exam. So, you want to at least be able to do it. It is usually for 1 mark, but every mark counts. So what you do is you express each of these terms. You find the square root of 1 here, which is 1, and you square it. And the square root of 4 here is 2. The square root of h squared is h, and I'm going to square it. and we taking the terms inside of the brackets here, and we are writing the difference of two squares. So this is 1 minus 2h, all right, multiplied by 1 plus 2h. Now we call these conjugates. Notice that the terms are the same. The only thing that are different here are the numbers. The only thing that are different is the sign between them, okay? All right, so let's look at another example here. We have here 9a squared minus 4b squared. All right, the square root here of 9 is 3. The square root of a squared is a, and we square in this. Square root of 4 is 2. Square root of b squared is b, and we square in this. We're taking the terms inside of the brackets, and we're writing here 3a minus 2b by 3a plus 2b. Let me know if this is clear with everybody. Okay, good. So I want you all to work out number 1 here. Okay, so this is x squared minus 49. The square root of x squared here is x, and we are squaring. The square root of 49 is 7, squaring here. So this could be expressed as we take in the terms inside of the brackets here and writing the conjugates. So x minus 7, x plus 7. How many of you all got that? For those of you who finished, work on number 2. Okay, so the square root of 25 here is 5 squared. So square root of 9 here is 3. So this is 3 here. Square root of b squared is b, and we are all squaring this. Now we will write the conjugate with the terms inside of the brackets. So this is 5 minus 3b multiplied here by 5 plus 3b. Those of you who are finished, move on to number 3, please. Notice here that you could also put 5 plus 3b multiplied by 5 minus 3b. Multiplication is commutative, okay? So if you have it the other way around, it's not wrong in any way. Okay, so the square root of 16 here is 4. Square root of p squared is p all squared, minus square root of 81 here is 9. Square root of q squared is q all squared. So using the terms inside of the brackets here to write the conjugates, this is 4p minus 9q multiplied here by 4p plus 9q. Okay? So move on to number 4 here. Okay, so this is 9a squared minus 4b squared. Square root of 9 here is 3. Square root of a squared is a all squared. Square root of 4 here is 2. Square root of b squared is b all squared. So using the terms inside of the brackets here to write the conjugates, this is 3a minus 2b multiplied here by 3a plus 2b. Okay? Good night, Declan. Okay, this example here is a little more complicated. I have seen it once in the past papers, but it's useful to know. This 2 is a difference of 2 squares. So this is already expressed as a square here, a minus b squared, and we could express here 1 as a square. All right, because the square root of 1 is 1, so when we square it, we still get back 1. And we'll use the terms inside of the brackets here to write the conjugates. So this is a minus b minus 1 by a minus b plus 1. I'll go it through again. A minus b squared minus 1. Remember this 1 here, we could express it as 1 squared and still get back this 1 because the square root of 1 is 1. Okay? We're using the terms inside of the brackets here to write the conjugate. So this is a minus b minus 1, a minus b plus 1. Okay? Let me know if this is clear with you all. Okay, and I want you all to factorize here, number 5. Okay, so a plus b squared minus 1 is equal to a plus b squared minus 1 squared, which is the same as a plus b minus 1 by a plus b plus 1. Okay, so that's correct. Just even though you write it the other way around, it's correct, okay? Like how you had positive 1 here and minus 1 here. Yeah, you don't like it. I know, I understand what you mean, Kyle, when you say you don't like it, because you know, it looks a little more scary, but CXC do give it for sometimes at least 2 marks, okay? Yes, all that is in algebra. Okay, well, this is difference of two squares. All you need to remember is this. A minus b multiplied by a plus b is an identity of a squared minus b squared. Okay? That's all you need to remember. So let's move on here to quadratic equation now. Now, the general form of a quadratic equation is ax squared plus bx plus c is equal to 0, where a is the coefficient of x squared. All right? This is x squared here. The coefficient is the number that multiplies the variable here, x squared in this case. Now, b is the coefficient of x. This is b here. All right? And c is the constant term. All right? So c is a number. Like a constant, it doesn't change. So a number doesn't change. All right. So we're going to do an exercise here of identifying values of a, b, and c in the following quadratic expressions. So in this first example here, the coefficient of x squared is 9. So a here is equal to 9. B here is equal to minus 12. And C here is equal to 4. Now please make sure you all could do this, okay? Okay. Now what we have here now in the second one, A here is still the coefficient of x squared. All right, it's always that. So don't just think that the first value here is A. Okay, it's the coefficient of x squared. So it's minus 81 in this case. B here is minus 9. And C here is 20. Everybody clear with that? Okay, so I have an exercise here of identifying the values of a, b, and c in the following quadratic expressions. So I want you all to work these out, please. Work these out. Now, while this is a very simple exercise, if you're having problems identifying a, b, and c, you will have problems factorizing a quadratic equation, using quadratic formula, completing the square if you're using the formula method, and so on, okay? And even when you are completing using the algebraic method as well. Okay? So please, while it may seem very simple, you need to understand the concepts, okay? A here is minus 3. A is the coefficient of x squared. B is the coefficient of x. Coefficient here is 1. And C here is the constant term 2. Okay? Minus 3. B is 1. C is 2. Okay, for the second one here, A is 16, which is the coefficient of x squared. B here is minus 24. And C here is 9. Okay? So work out the last one there. Okay, for the last one here, A is minus 14. B here is minus 55. And C is 36. Okay? So everybody clear with this lesson? All right, identifying the values of A, B, and C in a quadratic equation. All right? Now, what you will have many times is that you will have quadratic expressions, so you don't have an equal sign, and you will have a quadratic equation where you will put everything equal to 0. Okay? So just remember that, and A is the coefficient of x squared, B is the coefficient of x, and C is the constant term. All right, let's move on here. We'll be looking here now at factorizing quadratic equations. All right, so when you do this, many teachers will teach you either some different cases of factorizing quadratic equations, or they may show you a method that involves some level of trial and error. I created my own rules. I modified a little method here to their method to not have that headache of how to deal with cases or any trial and error. I like things simple. All right, I don't like to complicate my life with anything. So I make up a rule and the rule works well. All right, so I'll show you how you use it, and it helps you to solve factorize quadratic equations really easily. All right, so to factorize a quadratic equation, you identify two factors of AC whose sum is B. This is what you need to remember. Factors of AC whose sum is B. So you'll multiply A by C, all right, and look for factors of that product and see which ones you will use to come up with B. Now this is a key, all right? This is the key here. Always choose two factors that will maintain an even number of negative signs to ensure that the equations can be factorized. All right, this is the rule I created here. You want to make sure that you have an even number of negative signs. Okay, now obviously if the quadratic equation, let's say that all these quantities were positive, all right, then you would have zero even number, zero negative signs. Now zero is an even number. Okay, so this rule still works. Okay, so it doesn't matter whatever they give you, just maintain an even number. Choose factors so that you can maintain an even number of negative signs. Okay, all right. And so when you choose the factors, what you do is you apply what we learned last class in factorizing by grouping. All right, and we use factorizing by grouping to finish. So let me demonstrate how this is done, okay? All right, so they told us here to factorize completely 2x squared minus 5x plus 3. All right, so what you do here, and I usually would write out the possible factors in, well, the positive values of them to the right hand side somewhere, like a working column. Um, what happened is that after a while you'll be able to develop the skill of mentally doing it. But for now, I'll write it out so that in this lesson the students could see the thought process behind how you're doing it. And as you advance in practicing these questions, you realize you don't need to write it out. You would easily come up with the factors, unless it's more advanced one that you may with some bigger numbers that you may need to. Okay. All right. So here we have AC. A here is 2. C here is 3. So 2 multiplied by 3 is 6. All right. And I usually use the positive values of the product of AC because it's just to come up with the possible factors. All right. Remember, factors could be negative or positive. So 6 is the same as 1 by 6 and 2 by 3. All right. Those are the possible factors that you could find the product and get 6. Okay. All right. Obviously, it could be negative or positive as well. All right. So I'll write here 5x squared minus 5x plus 3. And we will ask ourselves here, notice that we have one negative sign here. I need to choose factors in such a way that I'll maintain an even number. I can't get 0, so I have to aim for 2. Okay? So if I try here 1 minus 6, notice I'll still end up with one negative sign, which is an odd number. So that definitely not works. So you're not going to have an issue of you're not going to have, thanks Nikolai. All right, you're not going to have an issue of trying to factorize with a problem, okay? So 2, we're going to use here minus 2 minus 3. So we have here 2x squared minus 2x minus 3x plus 3. Notice here that we have two negative signs. This is an even number, so that works out fine. Okay? All right, so what from here is factorizing by grouping. Okay, the HCF of the first two terms is 2x. 2x squared divided by 2x here is x, minus 2x divided by 2x is minus 1. We're going to repeat the brackets here, x minus 1, minus 3x. Remember, it's the third term that we divided by the first term in this bracket, okay? Minus 3x divided by x here is minus 3. We're going to factorize all the brackets here, x minus 1, and this is 2x minus 3. So based on from last class here, what you're doing, you're just applying the rule that I gave you here, that factors of AC must have a sum of b, and you're choosing two factors that will maintain an even number of negative sign. You come up with this line here, and we have, from here you apply factorizing by grouping. Okay, from here you're applying factorizing by grouping. So it's very simple. All right, so let's look at another example here. So we have 3x squared plus x minus 4 is equal to 0. All right, so 3 multiplied by minus 4 is minus 12, but I generally just write the positive values here, and we're going to write possible factors. So 1 multiplied by 12, 2 multiplied by 6, 3 multiplied by 4. Okay, notice here that currently we have one negative sign, so we need to make that 2 so that it'll be even. So we need to get here x. So I will choose here 4 minus 3, all right, and I will get back x here. So 3x squared minus 3x plus 4x minus 4. The HCF here of the first two terms here is 3x. 3x squared divided by 3x is x, minus 3x divided here by 3x is minus 1. We're going to repeat the brackets here. X minus 1, positive 4x divided by x here is positive 4. All right, factorize all the brackets here. X minus 1, 3x plus 4. Okay, so that's it working there. Let me know if you all are clear with this. Okay, go ahead and work out the first one here. Oh, I see some of you got a headset. For those of you finish one, work on two, okay? Okay, so I'm going to start here. 3x squared plus x minus 2. Notice here that 3 multiplied by minus 2 is minus 6, but I'm just going to write a positive value here. 1 by 6 is 6, and 2 multiplied by 3 here is 6. So those are the two possible products that we could examine, okay, for factors. So notice here that this is positive x. So 3 minus 2x will give x. So I'm going to write here 3x squared plus 3x minus 2x minus 2. Okay, you're seeing that these we have two negative signs, which is an even number. So this will factorize without any problems. So the HCF here of the first two terms is 3x. 3x squared divided by 3x here is x. Positive 3x divided by 3x here is 1. We're going to repeat the brackets. X plus 1 minus 2x divided by x here is minus 2. So this here is x plus 1, and this is 3x minus 2. Okay? Work on the second one, please. Okay, so 8 multiplied by minus 3 is minus 24. Just going to write the positive value of that product there. So possible factors, 1 multiplied by 24 here, 2 multiplied by 12, 3 multiplied by 8, 4 multiplied by 6. Those are the possible products there. Now, we want to get here positive 10, and we have one negative sign here already. So what we have to do here is to make it 2, make it an even number, okay? So notice here that 12 minus 2 will give 10. So this is 8x squared minus 2x plus 12x x minus 3. Okay? So the HCF of the first two terms here is 2x. 8x squared divided by 2x is 4x minus 2x divided by 2x here is minus 1. Repeat the brackets here. 4x minus 1. 12x divided by 4x will give me here positive 3. Positive 3 multiplied by minus 1 here will give minus 3. So that works out nicely. So 4x minus 1, 2x plus 3. Okay? Please let me know if the working is clear for you all. Okay, so I'm going to move on here now and do some more examples. Notice that the first set had one negative sign. These have two negative signs now. Okay, but the principles and the rules remain the same. Factors of AC must have a sum of B, and we always choose factors in such a way that we maintain an even number of negative sign. As I said, it doesn't matter. Okay, I'm just doing different types of problems to show you that it will work. Okay, so I'm going to write here 12x squared minus 17x minus 5. 12 multiplied by minus 5 is minus 60. So I'm just going to write the positive value here. 60 is 1 by 60, 2 by 30, 3 by 20, 4 by 15, 5 by 12, 6 by 10. Okay? Now, notice here that in order to get this this minus 17 here, okay, what I need to do here, I could use here minus 20 and 3. Okay, so this is 12x squared minus 20x plus 3x. I need to put this the other way around. Plus 3x minus 20x minus 5. Okay? So the HCF of the first two terms here is 3x. 3x squared divided by 3x here is 4x. 3x divided by 3x is 1. Repeat the bracket here. 4x plus 1. Minus 20x divided by 4x here is minus 5. Minus 5 multiplied here by 1 is minus 5. So factorizing all the brackets here, 4x plus 1, and we remain with 3x minus 5 in the other bracket. Is this clear with you all? Okay, so I'm going to work on another example here. 6 multiplied by minus 4 is minus 24. I'm writing the positive value here, 24. And we're writing out possible factors. 1 by 24, 2 by 12, 3 by 8, 4 by 6. O'Neill, thanks for joining us back again. These factors that I'm writing out here, usually I write them while I'm teaching, but after a while the students develop the capacity to mentally do this, okay? So you apply them to suit based on your abilities, okay? Okay, so notice here that we want minus 5, all right? And we need to maintain an even number of negative signs. So which means that one of the values that we choose must be negative and one will have to be positive to maintain 2. Okay? So notice here that I could choose here to get minus 5, I could say here minus 8 plus 3. So I will write this here as 6x squared plus 3x minus 8x minus 4. The HCF of the first two terms here is 3x. 6x squared divided by 3x here is 2x. 3x divided by 3x is 1. Repeat the brackets here. 2x plus 1 minus 8x divided by 2x here is minus 4. Alright, and minus 4 multiplied by positive 1 is minus 4. Factorizing out here, this is 2x plus 1. This here is 3x minus 4. Please indicate in the chat, let me know if this is clear with you all. Okay, the rules remain the same. Factors of AC must have a sum of B, and always choose two factors that will give you an even number of negative signs. Okay? So go ahead, work out number 3, please. For those of you who have finished with 3, you could work on 4. I left it on the screen so you could see it. Okay, so I'm going to start to factorize here. 3 multiplied by minus 10 is minus 30. So I'm going to write the positive value here. 30 is the same as 1 by 30, 2 by 15, 3 by 10. We have no value of 4, so we'll go with 5 by 6. Okay, so here we want here minus 13. All right, one of the values we need to choose here needs to be positive. Okay, because we want to maintain an even number of negative signs. So I would use here 15 and minus 15 and positive 2, because minus 15 plus 2 will give 13. So I will write here 3x squared minus 15x plus 2x minus 10. The HCF of these first two terms here is 3x. 3x squared divided by 3x here is x. Minus 15 divided here, minus 15x divided by 3x here is minus 5. Okay, I'm going to repeat the brackets here. X minus 5. The third term here, we will divide it by the first term here. 2x divided by x here is positive 2. 2 multiplied by minus 5 is minus 10. Alright, this factorizes here. X minus 5. And this here is 3x plus 2. Okay? How many of y'all got that? Okay, that's great. All right, you don't have to type out all the answers, all right? Because once I know that you get it, that's fine. All right, so work on number 4 there. Those of you who are finished. Okay, so we're going to work this out here. 12 multiplied by minus 5 is minus 60. I'm writing the positive value here. 1 by 60 is 60. 2 by 30 is 60. 3 by 20. 4 by 15. 5 by 12. 6 by 10. Okay, all these will give 60. So 12x squared minus 11x minus 5. And we want to get here minus 11. So we need to subtract here. One needs to be positive, one needs to be negative. Okay? Notice here that minus 15x plus 4x will end up here with minus 11. So this is 12x squared plus 4x minus 15x minus 5. So the HCF of the first two terms here is 4x. 12x squared divided by 4x here. This is 3x. 4x divided by 4x is positive 1. Repeat the brackets here. 3x plus 1 minus 15x divided by 3x here is minus 5. So this becomes here 3x plus 1, 4x minus 5. Okay, so let's do another, let me do some examples here now. All right, so notice here, this one has a positive, it has a negative coefficient of, it has a negative value of a. Okay, so what happens is that normally you would see the quadratic equations like these, they have them reverse looking like this because they generally put positives before negatives, okay? So sometimes, just for ease of writing, they would write things like that. So the principles remain the same, all right? Factors of AC, that will give us sum of B, whose sum is B, and you've chosen factors that will give you an even number of negative signs, all right? So 2 multiplied by minus 1 here is minus 2. So 2 is the same as 1 by 2. Notice that minus 2 plus 1 will give minus 1. So I'll use that here. So this is 2 minus 2x plus x minus x squared. The HCF of the first two terms here is 2. So 2 into 2, 1, minus 2x divided by 2 here is minus 2 minus x. Minus 2x divided by 2 here is minus x. Okay, repeat the brackets here. 1 minus x. Positive x divided by 1 here is plus x. Notice that x multiplied by minus x will give minus x squared. So we're going to factorize all the brackets here. 1 minus x. And the other terms, we put them in a bracket here. 2 plus x. Okay? So that's how you work those. Same rules, same principles, okay? Okay, so A here is minus 6 and C is 3. Minus 6 multiplied by 3 here is minus 18. So we write the positive value here, 18. 1 by 18, 2 by 9, 3 multiplied by 6. All right, so we could use that information there to come up with our possible factors. Notice here that we want to maintain an even number of negative signs. So I could say minus 9 plus 2 and get minus 7. So this is 3 minus 9x plus 2x minus 6x squared. So the HCF of the first two terms here is 3. 3 into 3, 1. Minus 9x divided by 3 is minus 3x. Repeat the bracket here. 1 minus 3x. 2x divided by 1 here is positive 2x. 2x multiplied by minus 3x is minus 6x. Factorizing all the brackets here, this becomes here 3 plus 2x. Please let me know if this is clear with you all. It's the same thing that we have been doing all along, same rules, just different types of questions, okay? Work on number 5. And those of you who finish very quickly can go on to 6, so at least write it down. Okay, O'Neill, if it works for you, no problem. You see, that's the beauty about math. All right? If that works for you, no problem. All right, I just use the even number of negative signs and that helps me. But if you look in the textbook, they really have several cases and no, it's not absolutely necessary, but this makes it a little easier to have a little order, especially later on when you working quadratic formula and so on. Okay, so here we have 27 multiplied by minus 1, which is minus 27. I just write the positive value here. 1 by 27. There's no value with a product of 2, so we go to 3. 9 3s are 27. Okay, so just these two. All right, so now here we want to get minus 6. So minus 9 plus 3 will give me minus 6. So this is 27 plus 3x minus 9x minus x squared. The HCF of the first two terms here is 3. 27 divided by 3 is 9. 3x divided by 3 here is x. Repeat the brackets here, 9 plus x. Minus 9x divided by 9 here is minus x. Minus x multiplied by positive x is minus x squared. So we're going to factorize out here. This is 9 plus x, and this here is 3 minus x. Okay? Work out number 6, please. Good night, Fabian. Okay, I'm going to start the work here. So we have here 3 multiplied by minus 4, which is minus 12. I'm writing the positive value here, 12, and I'm going to write the possible products that we could have. 1 multiplied by 12, 2 multiplied by 6, 3 multiplied by 4. Okay, so we're going to use these to come up with the factors that we will add to get b. So notice here that we have minus 4. All right, no, I could use here minus 6 and positive 2 to come up here with minus 4. So this is 3 minus 6x plus 2x minus 4x squared. So the HCF of the first two terms here is 3. 3 divided by 3 is 1, minus 6x divided by 3 here is minus 2x. I'm going to repeat the brackets here, 1 minus 2x. 2x divided by 1 here is positive 2x. Notice here that 2x multiplied by minus 2x will give me minus 4x squared. Factorizing all the brackets here, 1 minus 2x. This is 3 plus 2x. How many of y'all got that? Okay, I'm going to move on here now from factorizing the quadratic equations. We would have done 12 questions there. All right, so we look here now at solution of a quadratic equation by factorization. Now, I want you here to recall that the general form of the quadratic equation is ax squared plus bx plus c is equal to 0. A is the coefficient of x squared, b is the coefficient of x, and c is the constant term. Now, to solve a quadratic equation, we need to first of all factorize completely, and we need to equate each term in the brackets and solve for the variable. And I want you to note this, that if the product of two factors is 0, then one or both of the factors is 0, because you know anything multiplied by 0 is 0. So I'm going to demonstrate how to do this. So we have here 4x squared minus 64 is equal to 0. Notice that this is difference of two squares that we did earlier in the class. So we just factorize here. So this is 2x squared minus 8 squared is equal to 0. And we use the terms inside of the brackets here to write the conjugates. So this is 2x minus 8 by 2x plus 8. This is equal to 0. So we have factorized there. Now we need to solve here. We need to solve this. Okay? So we're going to take each of the conjugate and put it equal to 0. So this here is 2x minus 8 is equal to 0. 2x is equal to 8. Divide by 2, divide by 2. So we have here that x is equal to 4. In the same way, we have 2x plus 8 is equal to 0. 2x is equal to minus 8. Divide by 2, divide by 2. X here is equal to minus 4. So therefore, x is equal to 4, or x is equal to minus 4. Please let me know if this is clear with you all. Okay, good. So I'm going to do another example here. No, actually, you have questions to work. So work on these two here. Okay, so I'm going to start the work here now. So this is the difference of two squares. Square root of 121 is 11. So this is 11 all squared minus square root of 25 here is 5. This is all squared is equal to 0. We use the terms inside of the brackets here to write the conjugates. So 11x minus 5 by 11x plus 5. All right, this is equal to 0. Now, we place each of the conjugates equal to 0 and we solve for x. So 11x here is equal to 5, divide by 11, divide by 11. X here is equal to 5 over 11. Or we have here 11x plus 5 is equal to 0. 11x is equal to minus 5. Divide by 11, divide by 11. X here is equal to minus 5 over 11. So you have two values of x. 5 over 11 or minus 5 over 11. How many of you all got that? Go ahead and work out the second one, please. Okay, I'm going to start the work here. Square root of 9 here is 3. So this is 3 squared. Square root of 169 is 13. And square root of x squared is x. We square all of this. This is equal to 0. Now we'll use the terms inside of the brackets to write the conjugate. So this is 3 minus 13x by 3 plus 13x. This is equal to 0. Now we use the two brackets here, the two conjugates, to solve for the roots. So here we have 3 minus 13x is equal to 0. 3 is equal to 13x. Divide by 13, divide by 13. So we have here x is equal to 3 over 13. Okay, we take this second conjugate here. 3 plus 13x is equal to 0. So we have here 13x is equal to minus 3. Divide by 13, divide by 13. X here is equal to minus 3 over 13. So you have two values of x. These are your solutions. X is equal to 3 over 13 or x is equal to minus 3 over 13. Please let me know if you all got this. All right, so these here that we worked out here were difference of two squares. Now let's look at when we have to factorize. Thank you, Lovey. I was aware. I saw you posted it on Mr. Springer's channel. I was real happy for you though. No problem. Once you're getting through and you're moving on with life, I'm real happy for you. All right? Okay, so we need to use the HCF here to factorize this. The HCF of these two terms here is x. So x squared divided by x here is x. Minus 6x divided by x here is minus 6. This is equal to 0. So what we do here is that we take each of these terms here, the HCF here and what's inside of the bracket, and place it equal to 0. Remember, if this is 0, 0 by anything is 0. And if the value of x here makes here 0, then 0 by anything is 0. Okay? So what we do here is we put x is equal to 0, or x minus 6 is equal to 0, and we solve for x. So x is equal to 6. Okay? So that's how we solve that. Please indicate in the chat, let me know if you understand this. Okay. So let's look at these now. All right, so workout number 3 here. Just factorize using the HCF. Nikolai, don't forget that x is equal to 0 as well, okay? Aaron, that's correct as well, okay? You could express it as a decimal or fraction. Okay, so let's factorize here. The HCF here is x. 4x squared divided by x here is 4x. Minus 7x divided by x here is minus 7. This is equal to 0. So x is equal to 0, or 4x minus 7 is equal to 0. We solve here for x. So therefore, 4x is equal to 7. Divide by 4, divide by 4. X here is equal to 7 over 4. So therefore, x is equal to 0 or x is equal to 7 over 4. All right, so work out number 4 here. Okay, so the HCF here of these two terms here is x. 6x squared divided by x here is 6x minus 5x divided here by x here is minus 5. This is equal to 0. So this here therefore will give roots of x is equal to 0 or 6x minus 5 is equal to 0. 6x is equal to 5 divided by 6 divided by 6. X here is equal to 5 over 6. So therefore the two solutions, x is equal to 0 or x is equal to 5 over 6. Please let me know if you all understand this. You all getting this? I saw Aaron got it. Okay, good. Now let's look at this example here. All right, so remember that the general form of the quadratic equation is ax squared plus bx plus c is equal to 0. Anytime you want to factorize a quadratic equation, you need to move all the quantities to one side of the equation so you can have it in this form, okay, when you want to solve it. So this is 5x squared plus 9x is equal to 2. So we need to take this 2 across the equal sign. So this becomes here 5x squared plus 9x minus 2 is equal to 0. Okay? So 5 multiplied by minus 2 is minus 10. Okay? So we're going to write here 10, 1 by 10, 2 multiplied by 5. These are possible products that we could use to derive the factors. Notice here that 10x minus x here will give 9x, and I'll be able to maintain an even number of negative signs. So this is 5x squared plus 10x minus x minus 2 is equal to 0. The HCF of the first two terms here is 5x. 5x squared divided by 5x here is x. 10x divided by 5x is 2. Repeat the brackets here. X plus 2, this is equal to 0. minus x divided by x here is minus 1. Minus 1 multiplied by 2 here is minus 2. So we're going to factorize all the brackets here. X plus 2, and this here is 5x minus 1. This is equal to 0. So now we need to solve for the roots. Okay, so after you factorize the quadratic equation, this is what we were doing earlier in the class. We just take the conjugates, not the conjugates, we take the linear factors here and equate them to 0 and solve for x. So let's do that. So x plus 2 is equal to 0, x is equal to minus 2, and here we have 5x minus 1 is equal to 0. 5x is equal to 1, divide by 5, divide by 5. X is equal to 1 over 5. So therefore, x is equal to minus 2, or x is equal to 1 over 5. Okay? How many of you all got that? No, this was an example. My bad. All right? You all, these are the last two questions here we have for the evening. Can't believe I spent so many hours typing all of this and it gone by so quickly. Okay? So work on number 5 there, please. You could write down number 6 one side if you're working quickly. After I finish these two questions, I just need to show you the relevance or the meaning of finding the roots of a quadratic equation. I'll just sketch a graph and show you what it means. But that is the end of the lesson for tonight. Okay, so I'll rewrite this here as 3x squared minus 5x and bring the 2 across. This is going to become minus 2 is equal to 0. 3 multiplied by minus 2 is minus 6. So 1 multiplied by 6 and 2 multiplied by 3. These are the possible products we could use to derive our factors. Notice here that we want to get minus 5. All right, so minus 6 plus 1 will give minus 5, and I'll maintain an even number of negative signs. So this will be here 3x squared minus 6x plus x minus 2. This is equal to 0. The HCF of the first two terms here is 3x. 3x squared divided by 3x here is x, minus 6x divided by 3x here is minus 2. Repeat the brackets here, x minus 2, this is equal to 0. Plus x divided by plus x here is 1. 1 multiplied by minus 2 is minus 2. Factorizing out the brackets here and putting these terms here in a bracket. So we have these two linear divisors, so we can solve for them, the value of x. So x minus 2 is equal to 0, x is equal to 2, or 3x plus 1 is equal to 0, 3x is equal to 1, divide by 3, divide by 3. So therefore, x is equal to 2, or x is equal to 1/3. Okay? Anybody else got this? I saw Chazid have it. Okay, good, Aaron. Work out this last question here. Yes, it's minus 1 when you go across the equal sign. That is correct. All right, so it's minus 1/3. Shay, I'm leaving up the work in there, okay? So you could either take a screenshot of it. Okay, so I'm going to write here that this is 4x squared minus 11x minus 3 is equal to 0. Okay? 4 multiplied by minus 3 is minus 12. All right, so possible products here are 1 by 12, 2 multiplied by 6, 3 multiplied by 4. Now notice here that we could say minus 12 plus 1 and get minus 11 and maintain an even number of negative signs. So 4x squared minus 12x plus x minus 3 is equal to 0. The HCF of the first two terms here, this is 4x. 4x squared divided by 4x here is x minus 12x divided by 4x is minus 3. Repeat the brackets here, x minus 3, this is equal to 0. Positive x divided by positive x here is plus 1. 1 by minus 3 is minus 3. So factorizing out the brackets here, this is 4x plus 1, this is equal to 0. So let's solve here, x is equal to 3. All right, let me not run ahead here. X minus 3 is equal to 0, x is equal to 3, or 4x plus 1 is equal to 0, 4x is equal to minus 1. Divide by 4, divide by 4. X here is equal to minus a quarter. So Therefore, x is equal to 3 or x is equal to minus a quarter. Okay, I saw Nikolai have it. Anybody else getting this? Okay, excellent. All right, so this is the end of the questions. I just want to touch on this because many times students do these questions, but they don't have an appreciation for what exactly it means. So the meaning of the solution of a quadratic equation. So I want you to consider the following sketch of a quadratic function. Now, when you come to functions, you would learn that the coefficient of x squared, which is a, when a is positive, you'll smile and you will have a minimum function. And when a is negative, you will frown and you will have a maximum function. All right? And this is your x-axis. This is your y-axis. X-axis, y-axis. This is the origin. Okay? And what I want you to see here is that when we solve for the roots or the solutions for a quadratic equation, remember, it is always equal to 0 because the general form of the quadratic equation is ax squared plus bx plus c is equal to 0. The y value is 0. The y value is 0 at the origin. So what you're finding here are the x-intercepts. All right, so those solutions that you're finding here are the x-intercepts. All right, so we call them solutions or roots of the quadratic equation are the x-intercepts that occur at y is equal to 0. Everybody clear with that? Okay, so that's the end of the lesson tonight. Thank you for joining me. On Thursday, we'll be looking at completing the square and quadratic formula. All right, I will work on having everything typed up like I had today. It takes a lot of time to do it, but it makes the class flow faster. All right, so I will see you all. Have a good evening. Thanks again for joining me for class. Okay, goodbye.